All right, well, Steve, we got a bunch of great questions from our participants for you, so I'll start with that. But like I did last time, offer my personal observation. It really was stunning, the slide you showed to me, the comparison of Asotin and Bridge Creek. And I think that's been a big aha moment for me. Can you talk a little bit more about, kind of what you've seen on this topic of, like, you mentioned it once, but I want to reiterate because I think it's so important, this idea of habitat quantity versus quality, and that, the opportunity that we have to expand and actually get to that riverscape and, what that might mean. There are folks too also wondering, in more constrained urban areas and such, are there opportunities to do this, and can we benefit populations? And I think you've shown that even with a more confined system, that you still are able to do that just at a lower level. Can you talk a little bit more about that?
Sure. Yeah, I think it goes back to just the scope of degradation. I think we've all grown up with degraded streams and they've become the norm. And I think what Bridge Creek is showing is that there's so much of the riverscape that we've lost. And as fisheries biologists, we struggled for a long time trying to come up with habitat models, and they often were, saying we need more pools, we need more pools. And I think what the Asotin's showing is, yes, if you create more pools and more habitat complexity within a channel, you can get a fish bump, but that bump is fairly small compared to connecting to the original riverscape. And it's just a simple concept that area or amount matters. And we've lost an awful lot of fish habitat and riverscape. And if you really want to make a difference, you should try gaining that back. And if you're constrained, like you said, in a city, I don't think you've lost all hope. It's just you're talking about smaller increases.
Yeah, great. I mean, again, as a terrestrial person and coming from the world of sage grouse, I just see so many parallels here, because we found the same thing over the last decade. Most of our discipline is focused on managing these really small microhabitat features, right? How much percent cover of forbs or sagebrush or this or that, how tall is the grass for nesting? What we're learning is that the population level responses are coming from giving them more options and more area of sagebrush in general. And so we've done a lot of juniper removal and documented that type of response just by opening up more land to habitat in general. And so I think there's some lessons to be learned from that. I want to move on to...
Can I just throw it? Yeah. This just occurred to me. I mean, think about if you were a bison biologist and your goal was to increase bison. Well, 90% of the prairie is gone. So it's that kind of thing, right? You've lost a large part of what made bison, and it's the same for fish.
Yeah,
you can only get so much back unless without gaining what you've lost.
Great. Well, beyond just this potential effect size issue, several folks have asked, like, how do you determine which types of structures to use, PALs versus BDAs? What are you keying in on? And maybe we're jumping the gun a little bit on the rest of the workshop, but can you give them a little snippet of how to think about this?
Yeah, sure. I mean, in our case, we didn't want to muddy the waters by using these two different approaches. So we're focused on PALs, and our restoration plan says very explicitly that our goal was to increase this in-stream channel complexity first, and then in longer term get the the floodplain. If we were trying to restore a Soton Creek purely from just to restore it, we would have used a combination of PALs and BDAs, and generally speaking, we would use BDAs where we could see that there is readily accessible floodplain that we could access by getting that big backwater. But a lot of times we're finding that PALs are sort of the first line of attack because they're faster and cheaper to build because you're not trying to pond that water as much. You're waiting for the high flow to do the work for you. And as we've talked about with incised systems, you generally need to widen them and get some sediment moving first before you can agrade and connect to your floodplain. So the short answer is most restoration projects were using combinations of these structures. But in these experiments, we're specifically trying to test the two different approaches.
Gotcha. Okay. And are there plans now going forward? You know, were beaver present in that area, and are there plans to bring them back if not?
Yeah, it's been interesting. There were beaver dams on some of the streams when we started, and the management was still focused on removing those dams because they were thought to be barriers for the steelhead. And since we've built these structures, we haven't really seen an increase in beaver, and we've got another project on the other side of the hill trying to reintroduce beaver to a similar type stream. And the one thing the Blue Mountains are known for is fantastic wildlife density and diversity. And so it has some of the highest cougar densities in Washington state, as well as a healthy bear population. And it appears that beaver are having trouble re-establishing in these streams because they're degraded enough. There's not enough deep water for them to avoid predators. And as you just talked about in your talk, most of the animals are moving up and down these riparian corridors. So we have endless footage of cougars and bears walking up and down these streams, and beaver are just too easy pickings.
So the walking hot dogs, Nick called them.
Yeah, fur-covered hot dogs. Yeah, so I think that's a really important thing to sort of note is that the beaver are going to need some help to reestablish on their own because these streams are so shallow and degraded.
Got it. Okay, well, great. Thank you, Steve. I guess I'll ask Joe if there were a question or two for me before we move on. Joe, are you there?
Joe, you're currently self-muted. There we go.
Yeah, just talking to myself. It's all fun. Yeah, map.sagegrassinitiative.com is the site that Jeremy was referring to that you can go and play a little bit of those games. And so the softball question is just this is where you go, and it's under music resources. Okay. Next up, wow, they're just piling in here. Hold on. Yeah, so Jeremy, can you talk a little bit about whether or not this resiliency holds up in the face of grazing? You know, is this only a result in terms of increased productivity and resiliency that you can see if you get rid of the cows, or is it something that can coexist?
Great question. And I failed to mention there's actually another study that Trout Unlimited led there in that same sister watershed, Northern Nevada, that really looked at this issue of grazing, beaver, and climate resiliency and interaction. So you might check that out. That was Fessenmeyer et al. But what we're talking about there is not excluding livestock. They worked on the time and timing of grazing. And so when cattle are in the riparian zone, how much they eat, how long they stay. Those are the types of things we're talking about. Actually, simply removing livestock from the system, of course, it has some temporary benefits sometimes it can actually lock systems into those degraded stages, right? So Colin yesterday talked about that stage 3S, the arrested degradation. I heard Brian Kluwer refer to that as the zombie state. It looks like a pretty good stream. You know, it's got this narrow band of, you know, willows along it, but it's really locked in and armored, kind of like the system Steve works in with the alders. So I think now about phased restoration, where perhaps our first step isn't just removing livestock, but actually fixing the function of these systems, the hydrology, geomorphology, the biology all together. So yeah, I do think it's all possible.
Cool. I'm going to try and sneak in 2 quick questions, maybe 30 seconds each. One, just can you comment on, there was a few questions about this inefficiency principle, principle number 4, and just some concerns raised on messaging that. Any thoughts there? It basically concerns that this will upset water users in the American West.
I can't speak for every watershed. There's a lot of site-specific conditions, but I do work with ranchers every day, and I think ranchers know that the precip is getting more unpredictable, and it's not coming when they need it. So I think you need to work at a community-based scale, neighbors talking to neighbors about what's happening, and the fact that we need to keep water on the land, that water cycle, as long as possible, given that, you know, most of our irrigators, we only get that snow melt. And so if it comes as rain and it's gone by June, that's a problem for growing crops. We got to talk about that. So perhaps some natural storage in the upper watershed actually helps agriculture.
Yeah, absolutely. And any other, you know, water users, particularly larger scale water users, in the West will know that, you know, their puny little reservoirs are not the real reservoir. The real reservoir is snowpack, and that is threatened in terms of providing that delay with diminishing snowpacks. So yeah, great point. And then there's also a few questions just sort of getting at, it seems like what you're showing here in terms of vegetation productivity resilience response is only relevant in arid and semi-arid environments. Can you speak to that at all?
Yeah, you know, I do acknowledge our bias because of where we work, that this is how we've been thinking about this, but we have a lot of participants from other systems. And I have to imagine that even though water's not limiting, that biological complexity, the diversity of vegetation, you also have plants that are adapted for wetland and hydric soil conditions versus those that are more upland and drier species. So that composition change certainly occurs around the world and has consequences for species and ecosystem services that we depend on.